I'm Anil Kumar, and in this video we'll discuss few basic concepts about circles, sectors and segments. And I hope this will really help you to prepare for tests like SAT. Now let's talk about a circle. In a circle, all the points are same distance away from the center. That's the idea, right? So it is set of points which are same distance away from a point, and this point is called the center of the circle, correct? Now, the two terms, which is sectors and segments, before getting to them, let me talk about arc. So this circular path is kind of the arc, right? And the distance, the total distance all along the circle is called the circumference. Now, if I take a section of this, let us say kind of like this. In that case, this portion, which is kind of shaded, is called the sector. Right, so this shaded portion is called the sector. So this is the sector. Right? Now, in this sector, we can always find the area of this sector. As you can see, the area of this sector is proportional to the area of the whole circle. A circle, as you know, has infinite symmetry, right? So important point about a circle is that circle has infinite rotational symmetry. Right, that is kind of very important to understand. Now, if we have this angle of the sector as theta, let us say, in that case, the angle, if we measure the angle in degrees, let us say theta is measured in degrees, in that case, let me write down here theta measured in degrees, then the area of the sector will be equal to theta in degrees, and full circle will be 360 degrees, correct? Then the area of sector, or we can say sector area, they will be in the same proportion, sector area and the area of the circle. You know, area of the circle is pi r square. So let me write down pi r square. That is area of the circle. Similarly, if you are interested in finding the arc length, now what is arc length? Now this is sector's length. Let's call this as A, right? Now this arc length, we can call this as arc length A, or let me write arc length as a whole, divided by total circumference, right? And circumference, as you know, is 2 pi r. Is it okay? So pi r square is the area of the circle whose total angle is 360 degrees, and 2 pi r is circumference. If you're talking about a sector, in that case, the arc defined by the sector will be in the ratio of the angle which is subtended at the center, and even the area will be in the same ratio. That's the whole idea, right? Let's take up an example. For example, if we have this angle theta, well, let's do it here. Next question. So what we will do here again is we'll make another kind of an arc, right? And let us assume that the radius is 5 centimeters. And this angle over here is kind of, let us say, 85 degrees. Okay, I don't want to make it 90. Let it be 85 degrees. In that case, if you are supposed to find the sector area and the arc length, that means sector area, as you understand, is the inside area, right? So let's say the sector area is this area, right? Area of this sector. How much is that? Let's figure it out. So sector area will be equal to, you'll cross multiply, correct? So theta, the angle is given to you as 85 degrees. So 85 degrees divided by 360 degrees times pi r square. Pi r is given to you as 5. Is it okay? 5 square. So that is the sector area. So we have just cross multiplied to find sector area, right? And we can calculate this using a calculator. So it is equals to 85 divided by 360 equals to times, you can multiply by pi, or we can say 3.14, okay, times 5 square is equal to, so in decimals we can round it to one decimal place. It is 18.5 and the units will be centimeters square, correct? So that is how you can find sector area. As far as arc length is concerned, let's calculate that also. So arc length will be equal to, you have to cross multiply with the angle. So the formula will be theta in degrees over 360 degrees times 2 pi r, right? That's the formula. Is it okay? So you could simplify a bit and then do it, but we'll just place the values, use calculator. So 85 degrees divided by 360 degrees times 2 times 3.14 times 5. Okay, let's use the calculator. So I'm not really simplifying, we're just using the calculator. So we have 85 times 2 times 3.14 times 5, and we'll divide this by 360 to get the answer as equal to 7.4 centimeters. Do you see that? So that is how you can find arc length and sector area. Now let's talk about segment, right? So then the interesting thing to work here is for the segment. After all, what is a segment? Let me continue with the same example. So let's say our center is here. We are taking radius of 5 units and angle of 85 degrees. Okay. Now, if I join these 2 points, then this particular line which I have drawn is called the chord, right? This is chord. So the chord is this particular line. Let me use another ink. Okay, so this is the chord, okay? And the area formed between the chord and the arc, which is this area, is the segment. Okay, so that is the segment. Right. Now the question here is how to find the area of the segment, right? So that is the question. So the question which we are going to discuss now, so you understand what a segment is, right? We'll now discuss how to find area of segment. Okay. So what we are given here is radius of 5. We'll not redo these calculations, so that will save. And the angle of 85 degrees, correct? That is what is given to us. We need to find area of this segment. Okay. Now area of the segment which you can see here is, if you consider the sector, then it is area of the segment should be equal to this big area, which is sector area. Take away the triangle area. Do you see the triangle? Take away triangle area. Is it okay? So that becomes the area of segment. That becomes the area of the segment. So that is how you find segment area. Now, in this particular triangle, how do you find area of the triangle? Right? One way is you can use cosine law. These two sides are 5. We need to find the base, and we also need to find the height, right? So we also need to find the height. So there are two things which we need to find, height and the base. That is one thing. Second way is we can construct this triangle separately and then figure it out, which I am going to do just now. So let me just make an enlarged view of this triangle here. So it is kind of like this, let us say. Okay. Now we will drop a perpendicular from the center. That is the perpendicular, correct? Now we know that the sides are 5 units, right? This is 5 units. We also know what this angle is. This angle is half of 85 degrees. Is that okay? So this angle is half of 85. So let me do 85 divided by 2, which is equal to, in decimals, 42.5, right? So this angle here is 42.5 degrees. This is also 42.5 degrees. Is that okay? Since this is an isosceles triangle, both radius should be equal. We know this 42.5 degrees. Since we know this angle, we can find the other two sides, right? So let me name this. For example, let me say this is O, this is A, this is B. Let me call this as the midpoint M. So I'm saying this is M, this is O, this is A, and this is B. So what is AM equals to? So if you see from that angle, which is 42.5, half of 85 degrees, that's the opposite side. Is it okay? So we know sine of 42.5 degrees is equals to AM, the opposite side, over the hypotenuse 5. And so 5 times sine of 42.5 degrees is equals to AM, which is half the base, right? Which is AM. Is it okay? So we can find what AM is. Half the base. So it is 5 times sine of 42.5. That is equals to 3.3. So we'll write this as 3.78, right? This is AM. We'll not round it now. We'll round it later. Similarly, we can also find what is the height. Height is OM, right? So height OM is equal to, we'll do it on this side, okay. So height OM, we can find using cosine of theta, correct? So cosine of 42.5 is equals to OM divided by hypotenuse, which is 5, or OM equals to 5 times cos of 42.5 degrees, right? These are degrees. So that is 5 times cos of 42.5, which is equal to 3.686, right? All these are centimeters. So we know half the base. Now total base AB is equals to 2 times AM, right? Which is 2 times 3.378, and that is equal to, let's write it down. So it is, or we'll cancel 2 later, so let's not write it down. Okay, that's okay. You understand why I'm not doing it, right? Now, what is the area of triangles? So let's find out area of triangle, which is half of base, right? So which is half of AB, which is 2 times 3.378 times height, which is 3.686, correct? So this 2 and 2 cancels off. That is why I didn't really multiply. So let me multiply the other two sides. So we have 3.378 times 3.686, and that is equal to 12.45. Okay. So 12.45 is the area of the triangle. To find area of the segment, what should we do? We have to just take away from area of the sector. Is it okay? So we have area of segment equals to area of sector, which is 18.5. We're taking 18.5, which we already calculated. Take away this value, 12.45, right? And then we get our answer, okay? So it is 18.5 take away 12.45 equals to, in decimals, this is 6.02, so approximately 6 units, right? Which is centimeter square. So we get our answer, which is 6 centimeters square. Okay, so our answer is 6 centimeters square is the area of this segment, right? So I hope with this video you kind of recall what a circle is and how to work with the angle with the sectors and the segments. So we can find the arc length, we can find area of sectors and area of segments, as we have done in this particular example. You can also do all these calculations with angle in radians. It may become simpler when you're working with radians. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Thank you and all the best.